Assalamualaikum and hi everyone. In this video, I want to discuss the first chapter of Physics Matriculation course for the second semester, which is Electrostatics. So what you will learn in this chapter, you will learn about the electric charges at rest, the forces between them, and the electric fields associated with them. This is the overview of this chapter. You will learn about the Coulomb's law, and then electric field, and finally you will learn about the equipotential surface. Under the electric field, you will learn about the electric field strength, charge in uniform electric field, electric potential, and finally potential energy. First, let me introduce you the electric charges. There are two types of electric charges, which are positive and negative charges. Charge is a scalar quantity. The SI unit of the charge is coulombs, and we can use capital C as a symbol of the SI unit. Then we define the 1 coulomb. So 1 coulomb is a total charge transfer by a current of 1 ampere in 1 second. Charge is quantized. What I mean by quantized? Charge on any body is found to be integral multiple of charge on electron and never found as fraction of charge on electron. So I want to give you one example here. If you want to buy an eggs from the shops, we can buy 1 egg, 2 eggs, 3 eggs, and so on. But we cannot buy 1.5 eggs, 2.5 eggs, and so on. So, electric charge exists as discrete or packets and written as Q equal to NE, where E is a fundamental amount of charge, which is 1.6 times 10 to the power of negative 19 coulomb. Capital Q is electric charge, and capital N is a positive integer number, 1, 2, 3, and so on. Next, we go for the principal conservation of charges. What is the principal conservation of charges? It states that total charge in an isolated system or closed system is constant or conserved. Means that total charge is constant. That means total initial charge equal to total final charge. Let's say we are doing an experiment which has particle A with positive 3 coulomb, and this particle decay to 3 particles, which is B, C, and D. Okay. The B particle produced with 2 coulomb, and then particle C with negative 1 coulomb, and particle D with positive 2 coulomb. So if you see here, okay, for the particle A is 3 coulomb, and then total after A decay to B, C, and D, we got positive 2 plus with negative 1 plus with 2, so we got 3 coulomb. So this is meant by the total charge in an isolated system is constant. Means that total charge initial equal to total charge final. Now we are going to the first subtopic of this chapter, which is electrostatic force. Coulomb's law. So what is a Coulomb's law? The magnitude of the electrostatic, or known as Coulomb or electric force, between 2 point charges is proportional to the product of the charges and inversely proportional to the square of distance between them. Mathematically, we can write down F directly proportional to the product of the charges Q1 and Q2 and inversely proportional to the square of distance between them, R squared. Or we can write down the equation F equal K Q1 times with Q2 over with R squared, where F is a magnitude of the electrostatic force, Q1 and Q2 is the magnitude of charges, R is the distance between 2 point charges, and the K is the electrostatic or Coulomb constant, 9 times 10 to the power of 9 Newton meter square per Coulomb square. I want to give you one example. Let's say we have two charge, which is the first charge. Q1 positive 2 microcoulomb, and then near the Q1 is Q2 negative charge, Q2 is negative 5 microcoulomb, and the distance between them are, let's say, 1 meter. Then when we want to calculate the electrostatic force between them, so F is equal to K Q1 Q2 over R square. So we will substitute Q1 with magnitude charge, magnitude of charge Q1, which is 2 microcoulomb, and Q2 magnitude of charge Q2 5 microcoulomb. Don't put negative sign of 5 microcoulomb, just put it magnitude of Q2. So note here, sign of charge can be ignored when substituting into Coulomb's law equation. Okay. The sign of charge is important in distinguishing the direction of the electric force. So sign of charge here is important when we want to sketch the electric force of the charge. There are two types of electrostatic force, which are attractive and repulsive force. So first we see the same or like charge. What is same or like charge means that both are negative charge or both are positive charge. If the both of charge is negative or positive charge, means that it will produce repulsive force. So let's say we see the direction of the repulsive force on charge Q1 and charge Q2. So for the charge Q1, the repulsive force is to the left. Okay, and we will label it as F21. F21. So means that F21 is F of 2 on charge Q1. F of 2 on charge Q1. On charge Q1 means that we will draw or we sketch the direction of force on charge Q1. Okay. While for the charge Q2, the repulsive force, direction of the repulsive force is to the right. And we will label it as F12. F12. So now F12 means that F of charge Q2, of Q1 on charge Q2. On charge Q2 means that the direction of force is on charge Q2. Okay. From here, if we calculate the electrostatic force, we will get the F12 will equal to F21. The magnitude of F12 is equal to the magnitude of F21. But the direction of electrostatic force is different. Now we go for the opposite or different or unlike charge. Means that one is positive charge, another one is negative charge. So if the positive and negative charge, the electrostatic force produced is attractive force. Means that on charge Q1, the direction of electrostatic force is to the right, while on charge Q2, the direction of force is to the left. So we label it as F21. Means that F of 2 on 1. On 1 means that we will draw the direction of the electrostatic force to the right is on charge Q1. Okay. While for the F12 means that F of 1 on charge 2. On charge 2 means that we will sketch the direction of force on charge Q2. Okay, now we see the variation of electrostatic force with the distance between two charges. We have two types of graph here. One is the F against R, and the graph will be the curve graph. Okay, next one is the F against 1 over R square, and the graph will be straight line graph. Okay, from here we will get the gradient M is equal to K and the product of Q1 and Q2. It comes from the equation of F equal to K Q1 Q2 over R square, and then K Q1 Q2, and we separate the equation 1 over R square so that we can compare with y equal to mx plus c. So if you refer here, F is the y-axis, 1 over R square is the x-axis, and the gradient is K Q1 times with Q2. Just now I just discussed direction of force on both charge. Now I want to discuss how to draw force on each charge. So we go for the first diagram. Okay, let's say we have positive charge Q1 and positive charge for Q2. Okay, if we have Q1 and Q2 both are positive charge, you will know that it will produce repulsive force. Repulsive force between them. Okay, now please refer the equation. Draw the direction of force on charge Q2. Okay, the question asks us to draw the direction of electric force specific on what charge. So please refer here. The focus is you see the word of on charge Q2. So the direction of force we need to draw it on charge Q2 only. Okay. So how we solve this problem? So draw back the charge. This one is Q1, and then this one is Q2. Okay, so repulsive force means that it will repel to each other. Means that you will move away from each other. So you want on charge Q2. On charge Q2 means that your focus is on charge Q2 only. and then it want to move away from Q1. Move away means that it will move to the right. Okay, and then how you label to the right means that F of 1 on charge 2. So F1, 2. So this is how you draw the direction of electric force. Okay, next one is number 2. Diagram number 2. I give you another example. Okay, let's say we have negative charge here and then positive charge here, Q1 and then Q2. Okay, we have one is negative charge, another one is positive charge. Negative and positive will produce attractive force. Attractive force between them. Okay, attractive force means that it will move close together. So, please refer the question. Let's say question asks us to draw the direction of electric force on charge Q1. As I said just now, you will refer the word on. On means that it will refer on what charge. So on charge Q1 means that your direction of force is on charge Q1 only. Okay, Q1 only. So negative, we draw back. Negative Q1 and then positive Q2. As I said just now, the attractive force means that the direction produced is close together. It would toward to each other. But on what charge? On charge Q1. So the direction is on Q1 and then it will move to Q2. Because the direction is attractive force, right? So it will close together. So it will direction is to Q2 but on charge Q1. So how we label? So F of 2 on charge 1. Okay, let's continue with diagram number 3. The diagram number 3, I want to give you 3 charge. Q1 positive charge, Q2 negative charge, and Q3 negative charge. Okay, and then the question asks you to draw the direction of electric force on charge Q3. Okay, so our focus here is, please refer the word on. So on means that the direction of force is on charge Q3. You just focus on Q3 only. So let us draw back the charge for positive charge Q1, negative charge Q2, and negative charge Q3 here. Okay, we have 3 charge here, so you must draw the direction of electric force due to Q1 on charge Q3 and then due to Q2 on charge Q3. Okay, first of all, we draw the direction of Q1 on charge Q3 first. So we rub the Q2 so that you will not confuse with charge Q2. Okay, so Q1 on charge Q3, this is positive charge and negative charge. You will produce attractive force. Attractive force, and our focus is on charge Q3. So attractive force, it will attract to each other. Attract to each other means that on charge Q3, the direction is attract to Q1. It will attract to Q1. It will attract to Q1. So the direction is to the left. And how we label? F of 1 on charge Q3. So F1, 3. Okay, now we want to sketch or we want to draw the direction of electric force charge Q2 on Q3. So we rub the Q1 first. Okay, and then we draw the Q2. Okay, the Q2 is negative charge, so negative will produce repulsive force. Repulsive force, our focus on charge Q3. So repulsive force means that it will move away from each other. Move away from each other means that on charge Q3, move away from charge Q2. You want to move away. Move away means that it will repel. So it will produce to the right. So how we label? F2 on charge Q3. Okay, and then we just draw back the charge Q1 just now that we already rubbed it. Okay, so this is the direction of force on charge Q3. Okay, let's say we have from the same diagram, okay, draw the direction of electric force on charge Q1. Okay, what happens if the question asks to draw the electric force on charge Q1? Okay, Q1 is, I already said just now, you refer the word on here. On means that we need to draw the direction on charge Q1. Okay, on charge Q1. So our focus is on Q1. Draw first Q1 and then Q2 and then Q3. Okay, we will do one by one. The direction of force 2 on 1 and then F3 on 1. So F2 on 1, we just rub the Q3 first. Okay, so Q1 and Q2, positive and negative, it will produce attractive force. Attractive force means that it will attract to each other. But our focus on charge Q1 only. So means that it will attract to Q2. So we will label it as F2 on 1. Okay. So now the Q3 on 1, we rub the Q2 first. Draw the Q3. The Q3 over here. Okay, the Q3 is negative and Q1 is positive, so it will produce the attractive force 2. Attractive force means that it will move toward to each other on charge Q1, so it will move to Q3. The direction is to Q3. So you just draw the direction. You just stop out here. Okay, so F of 3 on 1. Okay, F on 3 on 1. This is F on 3 on 1. Okay, so if you see here, we will get both are same direction to the right. Okay, and then just put back the charge Q2 here. Let's go for the last example, diagram number 4. Let's say we have charge Q1 here, Q2 here, Q3 here. Okay, now please refer the question. Question asks you to draw the direction of electric force on charge Q2. So please refer the word of on. On means that on what charge, so on charge Q2. So your focus is on charge Q2 only, but due to Q1 and Q3. So please refer the Q1 on Q2. So Q1 on Q2, please rub the Q3 first. We will draw back after this. Okay, Q1 on Q2. Okay, Q1, Q2 is a positive and negative charge, mean that it will produce attractive force. Attractive force, it move toward each other. But on charge Q2. So on charge Q2. So Q2 means that the direction will move to the Q1. So we label it F1 on 2. Okay, and then we want to sketch or we want to draw the direction of force Q3 on Q2. So just rub this first. Okay, we draw back the charge Q3 just now. Okay, now we want to draw the direction Q3 on 2. Q3 on 2. Okay, Q3 on 2, this negative and positive charge will produce attractive force, means that move toward to each other, but on charge Q2, so it will attract to Q3. Okay, attract to Q3. So we label it F3 on 2, F3 2. And after that, we just put the charge of Q1 back. Okay, this is how you draw the direction of electric force on charge Q2.